The binomial theorem is a formula for the expansion of binomials. How do you raise a binomial to a power? We're going to be looking at patterns. So if you have this binomial raised to the first power, of course you just get a plus b. But if you were to square it out, meaning a plus b times a plus b and collect like terms, then you would get a trinomial. If you cube it, meaning you multiply the squared one times the first one and FOIL and multiply all that out and collect like terms, then you get a 4-term polynomial. One more example, raise it to the 4th power and now you get 5 terms. So notice the relationship between the power and how many terms you get. If you have the 2nd power, you get 3 terms, 3rd power, 4 terms, and so forth. Another pattern I want you to notice is the powers on A and B. So look at the powers of A. We have it to the 1st, then we have it to the 2nd, 3rd, 4th, but as we get here, it starts out with a to the 4th, a cubed, a squared, a, and this is really a to the 0, which is just 1. So this first thing in the parenthesis starts out with this power, and then it descends. But notice what happens to the b. We started out with no b's, which would be b to the 0, and then b to the 1st, b squared, b cubed, up to b to the 4th. So the first term descends, and the 2nd term ascends in powers. The other thing is, look at the coefficients. The coefficients here always start with a 1 and always end with 1. Now the middle stuff, that's where that binomial theorem is going to come in handy. But before we get there, we need to introduce a new notation. And here is the new notation. Parentheses with an N and a J. Some books usually use an R, but this one I'm going to stick with this book's notation. And this is read N taken J at a time. It really comes from probability and statistics. This is the number of combinations you can make with n objects taken j at a time. So let's say you had 5 objects and you chose 3 and you wanted to know how many different ways you could do this. That's what this formula gives you. Right, so we have nj. What does that stand for? It stands for n factorial divided by j factorial, and n minus j factorial. You do not need to memorize this. You do, however, need to learn how to use it on the calculator, and I'm going to show you that. So this, of course, is the TI-83, which you get to use on the test. So let's just practice it for a minute. Right, so if I have 6 is n and 4 is j, meaning 6 taken j at a time, I could memorize that formula, or I'm going to look in the calculator for these symbols. I'm going to have 6, and then this is the symbol I'm looking for. Notice the calculator uses an R instead of a J, and then 4. Alright, so of course we hit 6, and then you want to go to your math button, and you're looking for PRB, which is probability, so you can use your arrow button here to go right 3 times, or you can use your left arrow button and go backwards, and that gets you to PRB. And notice option 3 is that NCR. That's the number of combinations. The P is for for permutations. Right, so we want option 3, so we can just arrow down or just hit 3. And notice now we've matched what's on my paper, and now I hit 4. Enter. So that equals to 15. Now of course you could come back up here and say 6 factorial over 4 factorial over 2 factorial, and you would still get 15. Alright, let's try one more. Alright, so I'm looking for 48. I need this button, so I'm going to have 48, then go to the math button, and then again probability, so I'm going to go back 1 arrow using that one, and then option 3, and then punch in 20. Enter. And look at that huge number. Alright, so that is about 1.67 times 10 to the 13th power. Really big. Fortunately, we're not going to use those big of a numbers. So how does that relate to expanding the binomials? As we go back up here and expanding those binomials, I want to look at the coefficients. All right, so this coefficient is 2 taking 0 at a time. The second coefficient is 2 taking 1 at a time, and the third coefficient is 2 taking 2 at a time. If you punch those into your calculator, you're going to get 1, 2, 1. Let's look at this third row. All right, you're going to always start with the power. So this coefficient is 3 taking 0 at a time. This coefficient is 3 taking 1 at a time. This is 3 taking 2 at a time. And this is 3 taking 3 at a time. Now I want you to look at this bottom number, 0, 1, 2, 3. How does that relate to the powers on A or B? Well, it's the powers of B, because this one had B to the 0, B to the first, B to the second, B to the third. That's going to come important here in just a minute. All right, one more thing. So let's see here. That would be 4, 0. This is 4, 1. This is 4 taking 2 at a time. This is 4 taking 3 at a time. And this is 4 taking 4 at a time. And again, you can punch those into your calculator and you would get 1, 4, 6, 4, 1. So all of those patterns kind of arose in what's called Pascal's triangle. Now Pascal's triangle is a pretty cool thing used for lots of different things, but I want to show you how you can build it. It comes from those combinations, or you can start like this. Put a 1 in the middle, 1's on the outside, because remember those binomials always started with a 1, ended with the 1 as far as coefficients. So we have 1 and 1. Add those two numbers and you get a 2. 1, 1. Add those, add those. And if you go back and look at the coefficients of A plus B to the third power, you can see that those coefficients are 1, 3, 3, 1. And again, go back and look at that expansion and you're going to have those coefficients. So of course you could build this as big as you want, but sometimes that becomes tedious, especially if you have something like A plus B to the 20th power. That Pascal's triangle gets a bit large. But it is there, and I do want you to notice that it's symmetrical, meaning the numbers on the left are the same as the numbers on the right. You always have 1's. Those are your beginning and ending coefficients. Also notice something else. Look at that power. How does that power relate to the second term? Always the same coefficient. So lots of patterns today. That's what we're going to be looking at. So how are we going to use this NJ notation and expanding binomials? Well, let's just dive in and see. I want to expand and simplify this binomial. So the long way would be to multiply that all out and collect like terms. The shorter way is to use the patterns and Pascal's triangle, which would be for this row, or we could use those combinations. First of all, I want you to relate this to A plus B to the 5th power, and remember what happens to the powers of A. Remember, it starts out with A to the 5th, and then A4, A3, A2, A1, and A0. And B ascends. B0, 1, 2, 3, 4, 5. So all we really have to figure out are the coefficients, which we have from either Pascal's triangle or using those combinations. One more thing. What do these powers add up to? 5. And notice that's that. So all about patterns. So how am I going to write this out? So I'm going to say 2x plus 3 to the 5th power. I'm going to start out with 2x and I'm going to put it in parentheses. So I'm going to have 2x to the 5th power plus 2x to the 4th power. Now what are all those blanks for? Those blanks are the coefficients in front. Alright, so I've taken 2x, 5, 4, 3, 2, 1, 0. Okay, now I'm going to take the second term, which would relate to b. So I have a 3, want it to the 0 power, first, second, third, fourth, and fifth. So that one ascends. Now the last thing we need to do are the coefficients. Well, from Pascal's triangle, I know it starts with a 1, it ends with the 1. Then because of the 5, the second and the next to the last are going to be 5. And then of course there's 10 and 10. Now I just need to clean that up. Alright, so a calculator comes in handy. Of course that's 1. Don't forget to raise the 2 to the 5th power. So that's 32x to the 5th. This is 16 times 5 is 80. Whoops, times 3. Right, so I've got 2 to the 4th, which is 16 times 5, which is 80 times 3 is 240, and then x to the 4th. Right, so here I have 9, that's 8, that's 10, multiply that together, that's 720. Right, this is 4, this is 27, and that's 10, 1080, I think. And the last one, I have 5 times 2 times 81, that's 810. And then that's 1, and then I have 3 to the 5th power, which is 243. Now, even though that took a little bit of time, that is a much faster than multiplying out 2x plus 3 times 2x plus 3 again and again and again, and collecting like terms and hopefully not making a mistake. Let's do one more of those with a minus sign. I want to expand and simplify stuff with square roots. Oh, fun. Okay, so we have it to the 4th power. So again, I know I have a 1, and then I'm just going to put parentheses. So I have my coefficient, and so forth. And how many terms do I have? If I have it to the 4th power, I have one more than that. 1, 2, 4, 5. Right, so I'm going to take, again, this first one, the square root of x, and raise it to the 4th power. Third, second, first, 0. Now I know that's going to go away, but it's nice to just follow that pattern. Right, now I have a negative. So I have negative square root of y to the 0, negative 2. Oops, that's a 3, isn't it? 0, 1, 2, 3 to the 4th power. Alright, so now I can go use my Pascal's triangle, or I can use my combinations. Right, so remember, this is 4 choose 0, this is 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And I know from Pascal's triangle this is 1 and that's 1, and since that's to the 4th power, the second one in is to the 4th, as in the coefficient, and the next to the last. So again, I could punch 4 choose 2 in my calculator or look at Pascal's triangle, and either way I'm going to get 6. Now I need to simplify that. This is where it gets a little bit harder. Right, so that's 1. Now the square root of x to the 4th power, that's the square root of x, which is x, and then another one, so this is going to become x squared. Now I have a negative to a 1st power, so I know the next one's going to be minus. I got 4 times 2 is 8. And what is the square root of x to the 3rd power? Well, the square root of x to the 3rd power can be simplified like that. So I have an x, and I have the square root of x and the square root of y. Right, on the next one, since my negative is squared, I know that's positive, and I have 2 squared, which is 4 times 6 is 24. This squared is x, and that squared is y. Right, the next one, I have 2 cubed, negative 2 cubed, which is negative 8 times 4 is negative 32. And I have, since that's to the 3rd, again I can take out a y, and a y's left in. It's just like this one except with the y. And on the last one I have a negative 2 raised to the 4th power, so that's positive 16, and that's going to be y squared. So notice what happens when you have a minus, it alternates sign, and that's going to happen every time. So that's how you can expand the binomial, either by using those Pascal triangle or that NJ notation.